Good morning, dear students. Now, today we are going to discuss about the chapter probability. What is the meaning of the word probable? Probable. The word probable means chance, chances of occurrence. That means it is not 100%. There is a chance of getting something. It is chance. Now, before going to the section of probability, we will discuss about some terms related with the chapter probability. First of all, we are all familiar with experiments. What is a random experiment? What is the difference between a normal experiment and a random experiment? A random experiment means an experiment, a random experiment. A random experiment means an experiment that can be repeated infinite number of times. Repeated infinite number of times. Infinite number of times. But we cannot predict with certainty what the outcome will be, what the result will be. This is called as a random experiment. Now, when you perform a random experiment, you get some solutions or you get some outcomes of the experiments, results of the experiment. They are called as the outcomes. Outcomes of the random experiment, and the collection of all these outcomes, it is called as the sample space. Sample space, usually denoted by the letter S. So, we have to be very, very careful about the random experiment. In probability, we always deal with random experiment. And in random experiment, what is the probability of the random experiment? It can be repeated infinite number of times. But we cannot predict with certainty what the outcome will be. What will be the result? This is called as a random experiment. And the collection of all outcomes of the random experiment is called as the sample space. It is always denoted by the letter capital S. Let us consider a simple example. Consider the possibility of tossing a coin. Tossing a coin. When you toss a coin, what are the specialities you can see? You can see that either a head comes out or a tail comes out. So, the sample space consists of two elements, that is H or T. And the number of elements in S will be equal to 2. Number of elements in S is equal to 2. Now, let us consider another experiment of tossing two coins. Two coins. That is, you all know when you toss a coin, you get a head or a tail. So when you toss first coin, the outcomes are head or tail. Head or tail. When you toss the second coin, suppose if the first coin occurs in head, there can be two possibilities, either H or T. If the first coin results in a tail, again when you toss the coin, you can have the outcomes as H or T. So what about the sample space? Sample space consists of H, HH, HT, TH and TT.
Same coin or different coins? Two different coins.
Two different coins, or same coin is repeated twice. Same coin is repeated twice or two different coins. So, the sample space consists of n of s is equal to 4. Now, so when you toss a coin for the first time, you get the sample space is equal to 2 raised to 1 is equal to 2. When you toss a coin twice, or 2 coins are tossed, you get 2 raised to 2 is equal to 4. Suppose when you toss a coin 3 times, what about the sample space? Sample space. First, when you toss, you get a head or a tail. Suppose you have head. Again, when you toss, you get head or a tail. Suppose the first time when you are tossing, you are getting a tail. Then you toss a coin, you get a head or a tail. So, second coin.
Not second coin,
Same coin is repeated the second time. Now, when you repeat it the third time, you get a head or a tail. Here, too, you get a head or a tail. Here, you get head or a tail. Here, you get a head or a tail. So, when you consider this type of representation of writing the sample space is called as a tree diagram. Tree diagram helps us to find out the sample space quickly as well as more accurately. And what about the sample space? Sample space will be H, 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 T, H, T, H, H, T, 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 H, H, T, H, T, 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 H, T, T, T. That means number of elements in S is equal to 8. Number of elements in S is equal to 8. Therefore, thrice or 3 coins are tossed. It will be 2 raised to 3 is equal to 8. So, suppose if a coin is tossed n times, the sample space consists of 2 raised to n elements. The sample space consists of 2 raised to n elements. When you want to focus on probability, the first thing is you have to identify clearly what is the random experiment. That is, a random experiment means the experiment that can be repeated infinite number of times. You can repeat infinite number of times, but we cannot predict with certainty what the outcome will be. Such an experiment is called as a random experiment. So,
Sir, one doubt. This is for one coin tossing 3 times.
Yes.
If you have 2 coins simultaneously tossing, another tree will be there like this.
Another tree diagram will be there. So, a easy way of representing a sample space is by tree diagram, because tree diagram helps us to identify all the sample spaces, all the outcomes of the sample space. Now, this is called as a random experiment, sample space, outcomes, etc. and so on. Now, let us consider an example. I have written the question on the board. The questions will be given to you later. Let us consider a question. Specify the sample space. A coin is tossed repeatedly until a head comes up. A coin is tossed repeatedly until a head comes up. What about the sample space? So, when you consider the sample space, S is equal to a coin is tossed repeatedly until a head comes up. So, in the first time itself, you can get a head. Okay. Suppose in the second throw, you get a tail first and then a head. This is a chance. Now, in the third case, now if this does not happen, then you can get a tail or a head. Then you can get tail, head, etc. and so on. This is the sample space. Now, The second case is a coin is tossed 3 times. We have already seen what about the sample space when a coin is tossed 3 times. I'll write the sample space. S is equal to H H H H H T H T H T H H T T T T T H T H T H T T. Okay. So this is the sample space. So it is easy to find out the sample space. Now, what about the third question? A person is noting down the number of accidents along a busy highway during a year. So a person, the experiment is observing the number of accidents in the highway. So what about the sample space? In the sample space, there may be a day when there is no accident. Let it be equal to 0. In a particular day, there is only one accident. In another day, there may be 2 accidents. In another day, there may be 3 accidents, and it goes on. Next one. 2 coins, a 1 rupee coin and a 2 rupee coin are tossed once. Find the sample space. 2 coins are tossed. A 1 rupee coin you have seen and a 2 rupee coin are tossed once. Find the sample space. You have the sample space. S is equal to, but there is no need of confusion. A 1 rupee coin and a 2 rupee coin, because both the coins has head and as well as a tail. One side shows head, the other side shows tail. So what about the sample space? It is equal to HH HT TH and TT. Now, what is the meaning of HT and TH? Are they the same? HT means head shows first and then tail. TH means tail shows first and then head. Now, here we have come across 4 examples of the random experiments and the sample space. Now, you can clearly observe that in the first one, the sample space, this chapter has similarity with the set theory, because the sample space is denoted by sample space is denoted in the set form, where elements are written inside the outcomes are written inside the brackets, double brackets, and you can see that you can very well aware of the sets that this is an infinite sample space, infinite set. That is, there is no end. The experiment can be performed and it goes on and goes on and goes on. In the third case, a person is noting down the number of accidents along a highway during a year. The number of accidents can be 0. The number of accidents can be 1, 2, 3, etc. That means it is an infinite case. But what about the second and the fourth one? A coin is tossed 3 times. This is the outcomes. Number of elements in the sample space is equal to 8. So this means it is a finite set. It is a finite sample space. Similarly, the last one. 2 coins, a 1 rupee coin and a 2 rupee coin are tossed once. Find the sample space. This is also a finite sample space. Finite sample space. Whereas the first and the third, they are infinite sample spaces. Infinite sample space. Infinite sample space. I hope you understood what is the sample space, what is a random experiment, what do you mean by outcomes, and so on. Now, let us consider another example. toss a die. What do you mean by a die? You know that when you play snake and ladder, it's a cubical thing. And in each face, it is denoted by 1, 2, 3, 4, 5 and 6. It is called as a die. And when you toss a die, what about the sample space? The sample space can be 1 or 2 or 3 or 4 or 5 or 6, the sample space. And it is a finite sample space. Now, when you toss two dice, so there are two dice. Two dice are tossed. So what about the sample space? The upper portion, the top portion, it can show 1 1. 1 on one coin, 1 on one dice, 1 on the other dice. It can be 1 2, 1 3, 1 4, 1 5, 1 6. Or it can be 2 1, or it can be 2 2, 2 3, 2 4, 2 5, 2 6. I hope you're getting it. Then it can be 3 1, 3 on the first die, 1 on the second die. 3 1, 3 2, 3 3, 3 4, 3 5, 3 6. Or it can be 4 1, 4 2, 4 3, 4 4, 4 5, 4 6. Or it can be 5 1, 5 on the first die, 1 on the second die. 5 2, 5 3, 5 4, 5 5, 5 6. That means the upper portion on the first die shows 5, the second die, the upper portion shows 1. Upper portion shows 5, upper portion on the second die shows 2. Then it can be 6 1, 6 2, 6 3, 6 4, 6 5 and 6 6. This is the sample space when you toss two dice. So what about the sample space? Number of elements in S is equal to 36. It is finite and that is equal to 6 raised to 2. When you toss a die once, you may get either a 1 or a 2 or a 3 or a 4 or a 5 or a 6. That means it is equal to 6 raised to 1. Now, when you toss a die thrice, you can say that the number of outcomes of the sample space, it can be 6 raised to 3, which is equal to 216. If you want, you can write, but it is a tedious process. But you can count the number of outcomes of the sample space correctly, 216. Now, in this case, the number of elements, the elements of the outcomes that comes in the form 1 1, 2 2, 3 3, 4 4, 5 5, 6 6. They are called as the doublets. They are called as the doublets. So, when a pair of dice is thrown, the doublets is 1 1, 2 2, 3 3, 4 4, 5 5, 6 6. Now, when you add the upper faces on the dice, the maximum sum that can be obtained is equal to 12. Maximum sum that can be obtained is equal to 6 plus 6 is equal to 12. So this is the example of, this is also a finite set and the sample space is finite. So you can easily find out this sample space. Or what about the sample space in when you toss a die, when you toss two dice, etc. and so on. And you have to be very careful about the doublet. The doublets are 1 1, 2 2, 3 3, 4 4, 5 5 and 6 6. Okay. Now we will discuss some more questions on sample space, because sample space is very very important. That is the basis, because when you want to study probability, the sample space is very important. You have to identify the random experiment, and from the random experiment you have to study the sample space. An experiment consists of, the questions will be given to you later, but listen the question. An experiment consists of tossing a coin and then throwing it a second time if a head occurs. Tossing a coin. Toss a coin and then throwing it a second time. Throw it a second time if a head occurs. If a head occurs. If a tail occurs, on the first toss, a die is rolled. This is a question. Write the sample space. Toss a coin. An experiment consists of tossing a coin and then having it a second time if a head occurs. So, what about the sample space? Sample space. Tossing a coin. So, you can have a head or a tail. Toss a coin and then throwing it a second time if a head occurs. If a head occurs, again you throw it a second time. So you may get a head or a tail. If a tail occurs, suppose if the question is, when you throw a coin, if a tail is coming up, then a die is rolled. So when a die is rolled, you may get 1, 2, 3, 4, 5, 6. So what about the sample space? The sample space S is equal to HH, HH, HT, T1, T2, T3, T4, T5 and T6. So once again I'll explain. First experiment is tossing a coin. You may get a head or a tail. If a head comes up, then you toss a coin again. When you toss a coin, you may get a head or a tail. Suppose when you toss the coin, if a tail is coming up, then what is the next thing you do? You roll a die. I've told you what is a die. You roll a die. When you roll a die, you may get a 1 or a 2 or a 3 or a 4 or a 5 or a 6. In that case, what is the sample space? So S is equal to HH, HT, T1, T2, T3, T4, T5, T6. This is the sample space. Now, next one. A coin is tossed. A coin is tossed. And a die is rolled. So whenever you are asked to find out the sample space, it's better to draw the tree diagram because that gives you the clear picture of the sample space. A coin is tossed. Okay, a coin is tossed. You may get a head or a tail. And a die is rolled. So if a head occurs, a die is rolled. A tail occurs, a die is rolled. So you can have 1, 2, 3, 4, 5, 6. If a tail occurs also, you toss a die. 3, 4, 5, 6. 1, 2, 3, 4, 5 and 6. So what about the sample space? H1, H2, H3, H4, H5, H6 or T1, T2, T3, T4, T5 and T6. So the sample space N of S is equal to number of elements in the sample space is equal to 12. So using the tree diagram, you can easily draw the sample space and you can easily identify the number of elements in the sample space. Next one. I'll give you more questions to find out the sample space and you will do those questions as assignment questions. A coin is tossed and a die is rolled. A coin is tossed and a die is rolled. And a die is rolled only in case a head is shown on the coin. A head is shown on the coin. A coin is tossed and a die is rolled. Okay, a coin is tossed. You may get a head or a tail. Then a die is rolled only in case a head is shown on the coin. Only if head comes up, a die is rolled. So when a die is rolled, you get 1, 2, 3, 4, 5, 6. The question is, write the sample space. So what about the sample space? If a tail comes up, then you stop the game. If a head comes up, you toss a die. You roll a die and the possibilities are H1, H2, H3, H4, H5 and H6. So this is the sample space. So you have seen that the sample space can be a finite set or it can be an infinite set. So the study of probability, in the study of probability, the sample space, the importance of sample space is very important, and the outcomes are very important. Now you have to focus on the sample space, means you have to draw the tree diagram and then find out the sample space. Next one. What is meant by an event of the sample space? Event. Event. Event means any subset of the sample space is called as an event. Any subset. Any subset of the sample space. Any subset of the sample space is called as an event. So here the event, it can be E or even. Getting a head and an even number. Even. Getting, in the above example, getting head and even number. Even number. So it can be H2, H4, H6. This is an event because it is a subset of the sample space. Another one, E2, getting a tail. When you toss, getting a tail, it can be T. It can be T. Now these are called events, and events are all subsets of the sample space. Now when you find out the sample space, if there is only a single outcome, it is called as a simple event. It is called as a simple event. If there is only one outcome, it is called as a simple event. Now suppose when you toss a coin, toss a die, this is my random experiment, tossing a die, getting a number greater than 7, greater than 6. Now give me the answer. When you toss a die, getting a number greater than 6, you will say there is no such number, isn't it? So that event is called as an impossible event. Impossible event. Same thing, tossing a die, getting a number less than or equal to 6. Getting a number, tossing a die. That is a random experiment. Getting a number less than or equal to 6. It can be 1, 2, 3, 4, 5, 6. This is called as a sure event. It is called as a sure event. So you have studied the properties of probability, the properties, random experiment, sample space, infinite sample space, finite sample space, then events, simple event, impossible event, and sure event. These are the things that we have studied today. Now, one more thing we have to discuss today is about mutually exclusive events. Mutually exclusive events. Mutually exclusive events. What do you mean by mutually exclusive events? Let there be two events, E1 and E2. Here, E1 and E2. These two events are said to be mutually exclusive if E1 intersection E2 is equal to the empty set. If E1 intersection E2, that is, there should not be any common elements for both E1 and E2. Such events are said to be mutually exclusive. Let us consider an example related to the topic of mutually exclusive. Consider the simple example of tossing a coin, single coin. You may get a head or a tail. So E1 getting a head, E2 getting a tail. Now what about E1 intersection E2? E1 intersection E2 is equal to an empty set and it is called as mutually exclusive events. So for today, the topics covered are the sample space, random experiment, infinite sample space, finite sample space, events, mutually exclusive events, sure event, impossible event. And I'll give you the questions, copy the questions and submit them as assignment as given in the email address. So the first part of the section probability is over. And one more thing I have to tell you is about trigonometry. Copy down the formulas first, by heart them, and then we will move on to the section in detail. Okay, thank you.